Hello, everyone, and welcome back. It is Mr. Hine, and this lesson, 632, we're talking about how to differentiate log functions. So recall what we learned previously in that we know how to take the derivative of an exponential now, where we learned that the derivative of any exponential a to the x will be the natural log of a as a stretch factor, so remember that that's just a number, times the function itself. Good. Now, the goal of this lesson is, what is the derivative, what's dy dx, of a log function? So let's say log base b of x. What's the derivative of this going to equal? Okay, so let's look at an example, and let's see if we can figure it out now. So let's look at y equals log base b of x, so a generic log formula, log function, where b is any number greater than 0, but b can't be 1 because base is 1. 1 to what gives you x? Well, that wouldn't work out. So it can be any positive real number outside of 1. So we want to take the derivative of this function. Now, eventually, you got to take the derivative of this and say dy dx will equal, and you'll know what it is, but we don't know that yet. You will at the end of this video. We don't know that yet. So let's see if we can figure it out, because in case you don't know it, you could always build upon your foundations and refigure it out. So if we had y equals log base b to the x, and we want to take the derivative with respect to x of this function, the first thing we would do is we're going to rewrite this log as an exponential. So then this is equivalent to saying b to the y equals x. And then from here, when we take the derivative, if b is just, remember, a positive number, so we know how to take the derivative of exponential. So that's going to be the natural log of b times the function itself. But because of the chain rule, the derivative of the inside, so the derivative of the outside, which is natural log of the base times the function itself, leaving the inside alone, leaving y by itself, times the derivative of the inside, and the derivative of y is dy dx, is equal to, and the derivative of x with respect to x is 1. So that's a little implicit differentiation. Now, solving for dy dx, what we'll have here is then the derivative of this log function is going to be 1 over the natural log of b times b to the y. Now that's what it looks like implicitly, but remember that b to the y is equal to x at this step right here. So we actually can write this as the derivative with respect to x is the natural log of the base times x, because again, b to the y is x. And there is the derivative of a log function. Okay. Now, what if we said that's log? What about natural log? Well, remember, natural log is not a different log. It's just the log with base e. So recall that we're going to look at natural log in a second, but log base e is equivalent to natural log. Those are the same thing. And then remember, e is just a number. Euler's number, 2.17828, I think it is. So now let's do, what's the derivative of y equals natural log of x? Right? Doesn't change much. So we would say here, we're going to rewrite this because we don't know it yet, per se. We're wondering, can we do the same as a log? And let's find out. So let's rewrite this as, remember that this is base e, always. So we can write this as e to the y equals x. And then the derivative of e to the y is, if I was writing out the full definition, as a lot of you probably know it's just e to the y, but if I was writing out the full definition, it's the natural log of the base times the function itself. And then, because of chain rule, take the derivative of the inside, which is your dy dx, equals, and the derivative of x with respect to x is 1. Well, natural log of e is just 1, so we almost can ignore that. But I'm going to keep it there to show you that the derivative of natural log is 1 over natural log of e times e to the y, and recognize that natural log of e times and e to the y is x, so I could just write x. And this is what I wrote this out for a reason rather than simplifying, is notice that the derivative, this is the derivative of a log function, and this is the derivative of a natural log function. And I want to emphasize to you the point that they're the same thing. It's 1 over the natural log of its base. So the base here is any positive real number, which could be e. The derivative natural log is 1 over natural log of the base, but it's always e there, times x, and then times the inside there. It's really leaving the inside alone, which I'll show you in a second with chain rule. So really, natural log, I know I write it like that. A lot of times people just write that the derivative of natural log of x is 1 over x because of the idea that that goes to 1, right? But there's your generic formula. So if I summarize it down here, the derivative of any log base b to the of x is equal to 1 over the natural log of the base times x. Just remember chain rule. Chain rule will come up when we need it. Okay. And that's what this lesson's all about. Now we know how to do derivatives logs. Woohoo! Add that to our toolkit. Let's do a few examples and then be done with this video. Let's do an example of what's the derivative of log base 7 of x. And then we'll do another example. Let's do what's the derivative of log base 5 of 2x. And lastly, let's do the derivative of natural log x squared. Okay. And let's see if you can follow along with me, or maybe you can do this already faster than I can. So here we go. We could write this out and do it the long way, where you make it an exponential and then use implicit differentiation. Again, so if you ever forget the rules, rely on what you know. But we now know how to take derivatives log. So this is going to equal 1 over the natural log of its base, which is 7, times the inside, which is x. And there you go. That's your answer there. Here's the derivative of log base 7 of x. What's the derivative of log base 5 of 2x? Well, just be careful here. So it's going to be 1 over the natural log of 5. And then the idea here is that x is the inside of whatever you're logging. So here it would be times 2x. But because of chain rule, we have to take the derivative of the inside. So it's almost like the derivative of the outside, which is the 1 over natural log, leaving the inside alone, times the derivative of the inside. So then your final answer here is actually going to be 2 over natural log of 5 times 2x, which, simplifying that a little bit farther, we could write that as 1 over natural log of 5 times x. So just be careful with chain rule there, okay? And then the last one here, what's the derivative of natural log of x squared? So again, the shortcut is that it's just 1 over x. So that's like your little shortcut. But be careful memorizing that, because then you get very specific rather than generalizing. It's better to know the general form, because that works for all cases. So generally, or if you were using the shortcut with natural logs, it would just be 1 over the inside, leaving the inside alone. And then because of the chain rule, take the derivative of this, which is your times 2x. So then you would have 2x over x squared, which results in 2 over x. All right. Using the general formula with all logs, the general log derivative, it would be 1 over the natural log of your base, which is base e on natural logs, times the inside. And then because of chain rule, you'd have to do the times the 2x, which notice there, we're going to get 2x over, well, natural log of e is just 1, so you get 1 times x squared, which in the end, you get the same thing. So there it is. So there it is, derivatives of logs, and this lesson is about using that, understanding that, doing it a few times yourself, and then applying this within all the other derivatives we have in the product rule, chain rule, and quotient rule. All right. Hope that helps, and good luck making sense of it. I'm here if you need any help. All right. Bye-bye.